Good morning, everyone. It's 11:30. It's about 11:30. I'm going to do some of the problems, and we are recording this session. We are working on geometry, three-dimensional geometry. If you guys walk in, just feel free to interrupt. If you have any questions, it's not a problem. Let me make a couple of important announcements first. Your exam will be on Thursday. And tomorrow I will be available during our class time, which is 11:30 till 1, an hour and a half. We won't record a session, but I will be available at the Zoom link. You can come and ask questions. And other than that, the syllabus, I'm working on the syllabus for your exam. We call it study guide. And let's see. I'm going to add some geometry problems. I haven't added them yet, but let's work on a few, and I will add it by the end of the day. So you'll have your full syllabus here, and all exams are cumulative. You already know, and you want to take the exam. You cannot take more than 90 minutes. Most of you didn't need it, and you don't need it. These are 50-minute long exams. So take 90 minutes, but nothing more than that. Let's see if we can solve some problems today. What packet are we working on? Well, we are working on this packet. Okay. Now, we have done up to 12. We skipped, I think, only one problem from here that I won't give. Excuse me, I think we skipped number 6. Hi, Brianna. How are you? All right, Brianna, we are working on the same packet, and I'm recording, but it's not a big deal. You can always ask questions. And I'm going to start with number 13. Okay. We actually did number 13 last class. I'm actually going to start with number 14. As I told you guys, last class, we didn't do this problem because it was a little too hard. Let me bring another document, the one we were working on. Okay, so this is the document we used last class. It helps a lot because I kind of know where we stopped. We did this one. So we're going to work on this one. Okay, consider a large 7 by 7 by 7 cube made out of smaller 343 cubes. If you take 7 by 7 by 7, if you multiply 7 by itself 3 times, you're going to get 343. Fill out the following table without using real cubes. So it's a little tricky, but I'm going to try it. Okay. And since this, I'm going to do a couple of problems like this. So let me go ahead and bring it to my other page where we do our work. All right. So this is our problem. All right. So let me show you what a 7 by 7 by 7 cube looks like. Okay. Now, on the exam, you won't have a picture for this one. So try to understand it. And once we understand it, you're going to see you don't need a picture. I know I haven't even read the questions, but the whole question, but it's okay. We're going to read it. I hope I have a 7 by 7. If not, we'll find it. We'll work on it. We'll see. All right, then that's okay, guys. Okay, I don't have a nice picture. So what we're gonna do, and I'm not gonna make it now, it doesn't really matter. I am gonna do this problem, a so-called baby version of this problem first, okay, with a picture. That's my plan. So be a little patient, okay? And we're gonna learn from this problem. And that's gonna be the way we do it. Now, what do I mean by the baby version? I'm gonna do the same problem for a 4x4x4 cube. And that'll teach us enough about this problem, and hopefully we will be able to do it without a picture. If I give you this problem, I won't give you a picture. So I'm gonna say 4, 4, and 4. I think this is 64. So once again, guys, I'm gonna do a baby version of this problem, and I'm happy to do 2 baby versions first, okay? So let's keep the baby versions intact here. I'm gonna call it B. I'm gonna call it C, and let's do a 5x5. How are you, Brianna? Can you hear me?
Yes, I can hear.
Okay, good. And if you don't understand something, or if I make a mistake, I'm sure you're going to tell me. I appreciate your coming to class. Okay, so guys, once again, we're going to do an easy version first. Okay, and we have a picture. And I'm going to do a couple of things with you. I'm going to do this one with a nice picture of a cube. And again, if I give you this on the exam, you're not going to get a picture. Then I'm going to show you what kind of picture you can quickly draw and use to really answer the same question. You don't need a fancy picture like this. But since this is our first time, I am fine with a so-called fancy picture. So I have a picture of a 4x4x4 cube. All right, it's all stuck here. It's not going to go anywhere. So it says, I'm going to answer this later. Okay. Remember, guys, we discussed last couple of times that a cube has 8 vertices, 12 edges, and 6 faces. Always keep that in mind when you're doing these problems, when you're taking the exam. It's going to help you a lot. So how many, I'm going to not worry about the first one. How many cubes are showing one face? Well, they're going to be 4 per face, these little cubes. So the question really says, I have a large block made out of 4x4x4 cube. That means I have 64 cubes altogether. And that's exactly what I have in my picture. Find the following without using real cubes. So basically, I mean, of course you can use real cubes. Most of you won't have it floating around. So how many of these cubes show one face? Let's take a look, guys. I am doing one face first. We're going to come back and do 0 face. This has only 4 per face. And remember, a large cube has 6 faces. I have 4 on top, 4 in the bottom. So I'm not going to count and try to show you all. I'm trying to generalize. I'm going to say I have 4 cubes that shows one face, and they're on the 6 faces. So I'm going to take 4 and multiply it by 6. 6 coming from 6 faces, 4 per face. The answer is 24. Okay, that's not too bad. I'm going to erase this. I'm going to work on 2. I'm going to do 0 faces will be the last one I do. Okay, again, 2 faces. These 2 cubes here are showing 2 faces. Where are they located? They're located in the middle of each edge. How many edges does this big block of 64 cubes have? Remember, guys, they have 12 edges, 1 here, 1 here, 1 here, 1 here, 12 on the ceiling, 12 on the floor, 12 between the, 4 on the ceiling, 4 on the floor, 4 between the walls. I'm not going to draw all 12. I don't have to. So I'm claiming these two cubes. Let's even erase this. Okay, these two cubes that I circled in black ink are two cubes that show two faces. All the other faces are hidden. But how many groups of this kind of a pair of two cubes are there? There are 12 of them, and they're along the edges. So I'm going to take my 12 edges and multiply it by 2 and get 24. It happens to be 24, 24 for both, but that doesn't mean it's going to be like that for everything. Okay. And we're going to do one where it'll change. All right. Three faces are very easy. Three faces cubes are at the corners. And ask yourself how many corners are there? There are 8 corners. And three faces cubes, three face showing cubes are always going to be at these 8 corners. So I'm going to one corner, one cube per corner. There are 8 corners. So I'm going to take 8 multiplied by 1. I'm going to get 8. Now, altogether, there are 64 cubes. By the way, none of the cubes will show 4 faces. You just write 0. None of the cubes will show 5 faces. You just write 0. None of the cubes will show 6 faces. You just write 0. Now, when you add all this together, you're going to get 24 plus 24 is 48. Plus 8 is 56, if I'm not mistaken. Now, how many cubes are showing? How many cubes are showing 0 faces? Remember, the whole block is made with 64 cubes. 56 have been accounted for. If you take your 64, subtract 56, you're going to get your 8. So this answer is 8. Remember, we said we're going to do 0 later. So these are my answers. And you could argue that you could find 0 in a different way. You could say, you're going to take this cube and peel the cubes that show faces. You're going to peel all of this like an onion. And you're going to be left with a 2 by 2 by 2 cube. A 2 by 2 by 2 cube has really 8 faces. 2 times 2 times 2 is 8. And that's where this 8 is coming from. Let's pause here a little bit, see what's going on. Brianna, do you follow what we're doing?
Yes,
Any questions?
I'm good right now.
Okay, we're going to do one more. Okay, we're going to do one more. And if we spend a little bit of time here, be a little patient. I know this is a little hard. We're going to do one more. And then we're going to do one without picture. Then we're going to be ready for number 7. When I do this problem in class face-to-face, I go very slowly. I'm going to try this. Okay. I'm going to try this. And how do we do that? Very similar. I will try to draw a picture on this one. But I'm going to draw an easy picture. I'll tell you what I mean. So we're going to gradually move from concrete to abstract. The picture I'm going to draw is I'm not going to draw a real cube. I can just go here and add. There's nothing to it. Okay, if you want, I can do it. But I'm going to teach you how to kind of do it. That's our goal, how to do it without the picture. So I'm going to just right now, I'm going to draw one face, and a one face of a 5 by 5 by 5 cube will simply be a square that's 5 by 5. And it doesn't matter how you draw. Most of you will have a piece of paper, and you're going to have nice 5 squares. There's nothing going on here. Easy to draw. So this is one face of my cube, only one face. Okay, keep that in mind. I am going to use this to fill out the table. This is one face of my cube. It's very easy to draw. There is not a whole lot going on. And that's more than adequate. And hopefully the 7 one we do it without a picture. Or you can always have this picture on the side. There's nothing wrong with it, but don't bother drawing the whole cube. Remember, guys, remember a cube has 6 faces, okay, 12 edges, and 8 vertices. This is a V. All right, always keep that in mind. I'm not going to worry about the 0 faces, 1 face. Remember, these will be 1 face showing cubes. And that's going to be 9. But there are 6 faces. You're going to say 6 times 9 is 54. All right. 2 face showing cubes. Remember, guys, the 2 face showing cubes will be on the edge, and they're going to be kind of right here. Okay, I can see 3 faces. There are 3 faces on the top because it's a cube, really. So I will have 3 per edge, and there are 12 edges. 12 coming from 12 edges, 3 per edge. That gives me 36. And 3 faces is always going to be 8, guys. There are the 8 corners. There's always 1 cube per corner. I'm going to write it if you want me to. But that's the easiest one, this corner cubes. There are 8 of them. I know I can only see 4 here, the 4 behind. So it'll be 8 times 1 or 8. And this is always going to be for a cube 0, 0, 0. All right. Now, to find the 0 faces, I'm going to take 64. First, I'm going to add these guys up. 54. 54 plus 36 plus 8. And this is not too difficult to add. Of course, you can use your calculator. 18, 19, I think it's 98 if I'm not mistaken. There are 98 cubes I have accounted for. Something going on here. I have to fix it, okay, guys? Okay, so that's fine. Nothing is going on. My question has a little typo. It should be 125, okay? Because 5 times 5 times 5 is 125. Okay, so I have accounted for 98 cubes. They are here, here, here. I want to know how many cubes are completely hidden or showing 0 faces. So I'm going to take my 125 cubes, subtract 98. And if I'm not mistaken, that gives me 27. So there goes 27. On the exam, if I give you a table like this, and I will show you a table, you're going to enter these 4 numbers, okay? The best way to enter it, start from the top. You can say 0 faces 25. That'll be very nice. 0 faces 27, comma, 1 face, whatever, 2 faces. So you can enter it that way. Or if you enter it just the numbers, I will understand the first one is the first answer. 54, 36, 8. If you just enter those 4 numbers in the right order, I will understand that's what you mean. And ideally, you should enter 0, 0, 0 as well. Okay, that's how I kind of expect you to enter the answer. Now let's pause here just a little bit. Just a little bit. I'm going to do the 7 by 7 now. Before my answers are correct, I know that because I've done it too many times, but I'm going to write 125 here. I'm going to do the 7 by 7 for right now. Now I am going to, of course, you can always ask me questions. I'm going to draw a little table. Okay. It doesn't hurt to have a little, just a little 1-page table, just simple 1 face table. Okay, showing 1 face, it doesn't hurt. It's a good way to verify if you're right or wrong. Okay. Any questions from anyone? You can interrupt me anytime. Anytime. I'm going to take this guy, and this is here. I'm going to let go of this. I'm going to be, it's my one face of my 7 by 7 cube. And here's my problem. Here's my problem. And let's stick them here so that they don't move. You probably don't know what I'm talking about, but it's a software thing. You really don't have to. Okay, now it's a 7 by 7 by 7 block. How many cubes are showing one face? They're going to be right here. And if you count, there are 25 of them. But so far, I've accounted for one face. So I'm going to write 6. Excuse me. I'm going to write 6 times 25, which turns out to be 150. Okay, 2 faces. They're going to be, I'm going to do it in pink. They're going to be on each edge. And they're 5 per edge. There are 12 edges, and 5 of the cubes on each edge. In the middle of each edge will show 2 faces. 5 times 12. All right, this 12 times 5. And that's 60. And the 3 faces are at the corners. That's the easiest one. That'll always be 1 times 8 or 8. I'm not going to worry about this, guys. 0, 0, 0. Now, when you add these 3, 150 plus 60 plus 8, you get 218. All right, you have to subtract to find the 0 faces. You have to subtract 218 from 343. And I'm going to use my calculator. 343 minus 218. 125. Okay, so this is 125. Now another way to do the 0 faces, guys, if you can kind of see that it's a 7 by 7 cube, you're going to chop off the top layer and the bottom layer, so it'll be shrinking to 5. You're going to chop off the right and left layer, it's going to be shrinking to 5 again, and you're going to do the front and back. So it'll be basically a 5 by 5 by 5 cube that's completely hidden. That'll show 0 faces. That's another way of finding the 0 faces. So there you go. We have all our answers right here. How are we feeling, Brianna?
Good.
Does that make any sense to you, Brianna?
Yeah, that-
Very good. Now, I know I'm just talking to you now a little bit. I know you're following, but some of your friends will find it a little difficult. So if you don't mind, do you mind if I do another one like this? Or do you want to do it with me? How do you want to do it? I don't want you to get too bored.
no, you can do it on.
Okay, let's do one like this. I'm going to make it 8 by 8 by 8, okay? Or 10 by 10 by 10. So we are going to use the same technique. I'm going to write just one table, one face, I'm sorry. So let's do one. And I won't, tomorrow we are not recording. I don't even mind kind of stopping with this number, and you really want to practice. I'm doing a lot of them, okay? So I'm going to call it 14C. I'm going to call it, let's make it really large, 10 by, let's make it 11 by 11 by 11. Yeah, that's going to be a large number. And 11 to the power 3, according to my calculator, 11 raised to the power 3 is a large number, 1331. So we're going to work on this one. 1331. Okay. And I am going to get rid of this. Okay. Almost irrelevant. So let's see. And I am going to make it 11 by 11, a nice little cube. That's going to be my one face. So make sure you have some grid paper. You can sketch it. It's not going to be too bad. Eventually, actually, in my class, some of my students eventually say, I don't need a picture. I get it. And if you get it, if you can do it even without this, you're doing fine, actually. And I'm talking to everybody now. Okay, let's take this question to the next page. And I'm not gonna give you the grid for this one, okay? I am explaining it with the help of the grid. You won't get it. You can draw it if you really want to. In my class, I eventually ask people to come to the board and do it without any picture in their head. And most of them do actually a wonderful job. Most of them can do it. And I can do one without any picture if you want. I can do it for N too. Actually, we're gonna do one for N. Okay, the next one will be for N, and I won't use a picture. All right, guys. Let's see. Okay. So blah, blah, blah. One face showing cubes is going to be 9 by 9, which is going to be my 81. And I have to multiply it by 6 because there are 6 faces. I only circled one face. Made a bad choice, but we'll survive. It's a little too small. 6 times 81 equal to 6, 4, 8, 6. Guys, unfortunately, guys, I need a bigger picture. I can't write there. So give me 1 second, okay? And sorry about that. That's a little better. And I also need the table. Okay. So my one face showing cubes will be 81. It's your 11 minus 2 and squared, 81. But it really should be 6 times 81. And that turns out to be 4, 8, 6. And let me check. Yeah, that sounds about right. Two face showing cubes are on the edges. There are 12 of them. And there are 9 per edge. And where's 9 coming from? 11 minus 2. I'm going to write 9, but there are 12 edges. (108). And three face showing cubes is always 8. 8 at the 8 corners. I'm not even going to write. Well, let's write 8 times 1. 8 for the 8 corners. If you add them up, 486 plus 108 plus 8. I'm going to use my calculator. 486. And here's some I didn't. Okay. So 486 plus 108 plus 8 is 602. So this is 602. And this has to be 130, well, 1331 minus 602. And let's do it here. 1331 minus 602 is 729. That's a good sign. I'll tell you why. 1331 minus 602 is 729. And that 729 goes right here. Why do I know? How do I know I'm right? Well, remember when you peel an 11 by 11 by 11 cube, its dimensions shrink by 2. So if it's 11, it's going to be 9. So basically a 9 by 9 by cube is in the middle that you can't see, and the one that you can't see has 0 faces showing. And what's 9 by 9 by 9? Hopefully it's 720, 22, 729. So we know we got our answer right. So I did one, but so we basically did 4 parallel problems today. And that probably means you're going to see it. One version. And unfortunately, guys, my numbers only get bigger. Okay? And you really have to learn this. So let me develop a formula. Okay? If it's n, how does that look? All right? So let's do one with, and I'm not going to draw a picture for this one. Okay, Brianna, if somehow we get cut off, I don't think I'll need more than 10 minutes to do this one. I will always come back just to let you know. So I'm going to do this problem as follows. Hopefully you'll be able to follow everyone who's going to watch this later or is watching it now. And if I'm kicked out, I'll come back. That's the rule. So I'm going to make this problem. And I'm not even going to draw a picture. Why? Because you probably have seen the pattern. I'm going to take this guy and bring this guy here. All right, and make it a little bigger. Okay, so I made a tiny mistake that need to be fixed. N by N. And I will have to redo it just this little bit. Okay. Now, 5 is fine. What am I doing? Give me 1 second. There was no typo. Let's see it. N by N by N. Okay, guys. All right. This one is the easiest one. It's going to be always 8. Okay. Two face showing cubes are going to be in the middle. If this is n, this is going to be n by 2. And if this is n, this is also going to be n by 2. So there will be n by 2, n minus 2. Sorry, not n, well, n by 2 by n by 2. So how many cubes will show 2 faces in the middle of each face? And they're going to be n minus 2 squared. But you have to multiply it by 12 because there's 12. I take it back. You have to multiply it by 6. There are 6 faces. Okay. So we have accounted for 2 face showing cubes. Actually, this one is for 1 face showing cube. My bad. 6 times n minus 2 squared is the formula for 1 face showing cubes. Okay, this one, I'm going to scratch it off. 2 face showing cubes were here. There were 12 edges. So I'm going to write my 12 first so that I want to make sure I don't forget. On each edge, there will be n minus 2 cubes that show 2 faces. I'm going to multiply it by n minus 2. Now, you can write the zero faces using the n's you see here, but the best way would be to just write n minus 2 cubed. So that's a general formula for our cube formula. So we have developed it with, we started with a concrete block, we use one face, and then we have a now general formula. And I'm going to write the general formula right here because it looks nicer. So, and we're recording everything if I'm not, well, if it, now we have 6 minutes, that's plenty of time. So this is going to be 8, and two face join cubes will be 12 times n minus 2. And this guy, one face join cubes will be 6. There's 6 faces, but this time it'll be n minus 2 square. Why square? Because in the middle of each face, there's a little square that is n minus 2. That is showing one face. Zero faces will be, will be simply n minus 2 cubed. So I wouldn't encourage you to use the formula. I would encourage you to do it. Why are we doing it? Let's talk about that a little bit. Okay, problems like this show up in middle grades text, okay? Some of your kids won't be ready for this kind of formula. Some of them will be, some of them won't be. So the point here is you will have a nice formula. You can check your answer. You can make your questions. You will have the power to teach, big numbers, but your students should do it from scratch and basically derive the formula for whole numbers. And you should know a little more than your students. So here's the formula for the whole thing. And I know this is being recorded, so that's a good thing. I'm gonna bring it to that table so that when you watch your video, you can see the clean formula. Does this make any sense, Brianna? Okay, right here. Okay, guys. Now this is going to kick me out. I plan on doing one more problem, okay? And that will be the cutoff line. I'm going to get out of this session. I'm going to come back, record a short session, not a very long one, short session. We spent about 50 minutes there recording. So I'm going to do one more problem for you guys today. All right, guys, I'm getting out of here and I'm coming back right away. See you soon. Those of you who are in class, see you soon if you want to come back.